What's going on, everyone? Welcome back to another video for the AI for Aspiring Researchers lecture series. In this video, we're going to be going over clustering. Now, this video is going to be a short video, but we'll be giving examples on how to actually create your own data set to test clustering, and then two different examples or algorithms for clustering, which are K-means and the Birch algorithm. So let's jump right into it. So the first thing that we're going to do is import our libraries. So the first one is going to be import matplot. Let's first actually connect. The first one that we're going to do is matplotlib.pyplot as PLT. And this is specifically so that we can see the different clusters or blobs that are actually forming from whatever data set that we generate. And the next four libraries are going to be new, so we're going to take a look at them. So we're going to say from sklearn.datasets, sklearn.datasets, we're going to import make blobs. And so what this is going to do is it's going to allow us to actually create the different blobs or the different clusters required for training or actually running our algorithm. And then that's going to be the first one. Then we're also going to see from sklearn.datasets, we're going to go ahead and import make circles. And so this is going to be the second thing that we're going to look at. So the first type of clustering we're going to look at is blobs, or just kind of a typical cluster that you would expect. And then make circle is actually going to create or generate points in the shape of a circle or a couple of circles, and you'll see exactly how that classification works as well. Alright, so the next thing that we need to do is actually import the libraries that contain our algorithms. So we're going to go ahead and say from sklearn.cluster, we're going to import KMeans. From sklearn.cluster, we're going to go ahead and import Birch. Cool, so let's go ahead and run that. Oh, did I spell that wrong? Where did it here? SKlearn. Okay, awesome. Oh, make circles. Okay, there we go, finally. So, as you can kind of tell from the libraries, this video is kind of going to be really preliminary, because the nice thing about SKlearn is it provides both the algorithms and like the actual implementation of said algorithm, so we don't have to go ahead and implement it ourselves. And it also provides the actual generation of these different data points for our clusters. So you see make blobs, make circles, that's what allows us to generate all the data that we require to run these algorithms. So the first thing that we're going to do is actually use the make blobs, and we're going to assume that we have 5 blobs for now, and these are going to be essentially the same thing as saying 5 different clusters. And then what we're going to say is x comma y is equal to make blobs, and then we're going to feed in n samples of 500. Now what this means is that we're going to generate 500 different data points. We're going to say n features is equal to 2. Now this is kind of, you can think of your x and y axes. And then centers is equal to blobs. Right, so this is essentially saying that there are going to be 5 different centers or 5 different clusters equal to the number of blobs that we said, which is 5. Right, and then we're just going to say a random state equals 2 for recreatability. Alright, let's actually do 10, because I want to show you one thing before in the 10, so I think it'll show it better. So then we're going to say plt.scatter, this is the typical scatter plot, and then what we're going to do is say x colon comma 0 to get all the values in the first column, which is essentially going to be your x values of these coordinates. Then you're going to go ahead and say x colon comma 1. Now this is going to be all the values in the second column, which are going to be the y coordinates. And marker, so this is going to be marker is equal to an upwards triangle, or a triangle. And then finally c, which is denoting color, is equal to y. Right, so y over here, make sure you know that y over here is not necessarily talking about, it's not talking about the y-axis. The y-axis is actually in the x. The x contains all the coordinates of all the points, whereas the y is just the classification of said point. And so that's why we toss in color equals y, because this y determines the classification of a point determines its color. Okay, then we're just going to say plt.show. Okay, so you can automatically see that we have 5 different blobs or 5 different clusters that we've created through using this make blobs function. And you can see them very far apart from each other, right? And so what we're going to do is say now a random state of 2, and you'll see that if we say run our k-means or Birch algorithm on this, it's fairly easily going to separate them into different clusters, right, or different colors. But if we say had points that were more closer together, then the algorithm would make, or it would make it much more difficult for the algorithm to determine which essentially classification this is. And so if we say a random state of 2, you can see that right here. Right, so over here you kind of see that this teal color and this yellow color are merging in a sense, right? So there's some values that go with the yellow color right in this area while some are teal, and so the classification algorithms might have some problem essentially seeing those. And so we'll take a look at k-means first and how that actually works with separating these. Okay, so we'll say model is equal to k-means, and then we're going to feed in n clusters is equal to blobs, right? Because we want the k-means algorithm to determine 5 different classifications, since that's the number of classifications that we had initially as well. So we're going to say that, then we're going to actually fit the model to our coordinates, right? The coordinates that we face. But note that we're not feeding in any classification. That's the point of the model. Model is to predict what classification is a point given the coordinates, and that's what we're feeding in. We're feeding in x. Okay, then we're going to say pred for prediction is equal to model.predict, and then we're going to once again feed our coordinates, because now what this is doing is it's actually taking these coordinates and predicting what is the classification for them. Okay, so then we're going to say plt.scatter, and now what we're going to do is we're going to do the same thing as we did up here. So we can just actually copy paste this essentially. Okay. And instead of y this time, what we're going to do is say pred, right? Because these are our new predictions for the classifications. Y were the actual predictions for the classifications. And what we're going to say is plt.show. Okay, so you can automatically see that the k-means over here just split it down the line, right? So you see, essentially, you can draw a imaginary line right here, and everything to the left is this green color, and everything to the right is yellow. And so that's essentially how the k-means algorithm goes about clustering. And you see up here, obviously, most of the, or all the points actually were clustered properly. Down here, same thing. Over here, for the most part, I think probably everything is clustered well, and over here all it did was it just broke a line down the middle and assumed that everything once again to the left was green and to the right was yellow. So that's the k-means. Now what we can also see is we can see it for the Birch algorithm. Now this is just another algorithm, and it performs a little differently. So we'll say model is equal to Birch, and once again n clusters is equal to the number of blobs. And now what we can also do is we can just copy paste, because this entire thing is going to be the same. It's just the model now is different. Rather than training this model with the k-means, we're using the Birch algorithm. So we can just copy paste everything else, and let's go ahead and see what it gives us. Okay, so the Birch algorithm gave us something different, right? So in k-means, we said that we could imagine this line that was going right through, and it makes a clear, distinctive classification. But over here, what it's doing is something a little different. It's actually this purple color is kind of, or the algorithm is classifying these points over here as this purple color, whereas this one, these points down here as this yellow color. And so the reason it's doing that is because the classification model is just different. The way it predicts these points, or what classification these points are, is just different from k-means. And so you'll see these different classifications, and sometimes you just kind of have to test out different algorithms to see which one works best. In my opinion, k-means typically works really well a lot of the time, and is probably the more popular algorithm. So if you are encountering a classification or clustering problem, I should say, typically you would want to try K-means algorithm first, because that's the first thing that pops into my head, or mostly anyone's head for that matter, when they think of clustering. Okay, so these were with making blobs, but now I also promised that we would go ahead and make these circles. So let's go ahead and see what exactly happens there. So now what I'm going to do is I'm going to say xc and yc, so not to be confused with the x and y from blobs, but xc, yc just means x circles, y circles, and then we're going to say make underscore circles, and we're going to feed in once again n samples, so n samples equals 500. So that's once again just going to say that we are generating 500 different points for our graph, and we're going to say random state is equal to 2. This is just once again for reproducibility. Okay, so then what we're going to do is we're going to say plt dot scatter, and we're going to say xc, and then once again we're going to get all the values in that first column, followed by all the values in that second column. These are the y values, right? So these are the x values in the first parameter, and these are the y values of these coordinates in the second parameter, and we're going to say marker. This time we're just going to say marker is equal to a point, and c is equal to yc, because remember, yc is not the y coordinates, but instead it's the actual classification or the colors that are classifications for each one of these coordinates. And we're just going to say once plt.show. Okay, so you can obviously see that there are two circles, or two concentric circles, that are formed. This outer circle is purple in color, this inner circle is yellow in color, and what we're going to go ahead and do is we're just going to run the K-means clustering algorithm on it and see what the output is. Okay, so we're going to say model is equal to K-means, and this time we're going to say the n clusters is equal to 2. Let's try 2 first, because we see these two different classifications. Well, maybe 2 will work. Then we'll go ahead and say model dot fit, and then xc, so it's going to fit our coordinates on this model, and then we're going to go ahead and say predc is equal to model dot predict, and then x or little c. So this is going to predict based on the coordinates that we see. Then we're going to say plt, or actually let's just go ahead and copy this whole thing, and we have to change, instead of yc, we're going to change it to predc, because these are the predictions. Okay, so instantly what you can see is that this prediction is not as good as the blob classification, because in this one it's obviously the inner circle that's yellow in color, or one class, and the outer one is a different class. But here what it's doing is it's just taking a line right down the middle, or right diagonally, and saying everything to the left is yellow, everything to the right is purple. And well, that's not necessarily the best way that we can go ahead to classify these circles. So maybe we can try breaking this up into more clusters. So let's try 8. And once again, it's kind of just doing the same thing, right? So it's just breaking these little portions into different classes and different colors, and that's what it's plotting. And so the reason it's doing this with the K-means clustering algorithm is because just the way it works. K-means, what it's doing is it's trying to find the points that are closest to each other. So in this case, it's finding points that are closer to this center right here, which would include not only the points on the outside, but also the points on the inside circle. And so if I say we're to take a center right where my mouse is, the closest points to that center, or the closest points, or I guess, yeah, the closest points to this center where my mouse is, are going to include the purple points, and similarly over here. But these points on the outside are not all going to be the closest over here, and that's why this little section is purple, or classified as one class, as opposed to this whole outer circle being one class and this whole inner circle being one class. And so that kind of explains clustering at a very basic level. I would definitely recommend you guys check out different algorithms. There's more than just K-means and Birch, and some are pretty cool. And test them out for yourself. See however many different classes that you can create, and however many different clustering algorithms that you can run on them, and basically maybe even try it on the iris dataset. That's definitely a good dataset. We've seen that in the past, and you can definitely check that out with clustering over here. But for now, if you like this video, make sure to subscribe, leave a comment, like, and share, and I'll see you next time.